All right, I apologize. So the side splitter theorem. The side splitter theorem states that if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides those sides proportionally. So what this is saying is that AC, the ratio of AC over CE equals AB over BD. Now, just like with other chapters, you can do this in more than one way, as long as you're, other sections, as long as you're maintaining an order. So some of the other things we might see, we could say that AB, I'm looking at a different example. We could go with AB, the ratio of this over AC is going to be equal to BD, this little piece here, over CE. All right, so there's two different ways that you could set up the same problem. So let's try this with example 1 here. Find the value of X. We have this line parallel to this line, so it is creating an intersection here that is that will form a proportion. So I know that the ratio of 2 over the rest of this side length over 4 is equal to, so 2 over 4 equals X over 7. And now we are in a situation again where we simply cross multiply. We get 4X is equal to 14. Divide by 4. X is equal to 7 over 2. Or we could simplify that as 3/5 or 3.5. So this one's pretty obvious. This piece right here is half of this piece. So this piece has to be half of this here, which is where we get the 3.5. So here are a couple other examples. Okay, I know, remember, you can set it up in several different ways. 12 over 14 is equal to, so I went here over here, so now I have to go with what's across from the 12, 15 over X. I cross multiply and solve. So I get 12X equals 210. Divide by 12, and I get X is equal to 17.5. So this length right here is 17.5. All right, same thing here. You can go across from each other. X over 56 equals, back over to this side, 18 over 21. Cross multiply. We get 1008 divided by 21. X is equal to 24. All right. Sorry, 48. All right. So there are a couple more problems here. Let me see. These ones are getting a little trickier because in this case, we don't know the side across. So X, I know that X over 36 equals, well, when I look right here, I don't actually have the value. So you have to do a little bit of work. The entire side length is 55. This is 45, so this has to be 10. 10 over 45. Cross multiply and solve. Same thing here, you would need to find this missing piece, so we subtract 6 from 27, and now we have the same thing. This also very similar, except now we're going to see an expression here and not just x. So I can say that 30 over 25, boom over boom, equals x plus 7 over 15. Cross multiply. Don't forget your parentheses around the x plus 7. Now there's a corollary to that side splitter theorem. And that simply states, you're going to see a similar shape, but it's not going to be a triangle. If three parallel lines intersect two transversals, remember transversal is just a line that cuts through the two lines or more. The two transversals, then the segments intercepted on the transversal are proportional. All right, so I'm going to draw, let's start with our three parallel lines. They're all parallel because they have that arrow there. And then we have two transversals. We'll call these intersections A, B, and C, and we'll call these D, E, and F. So you can kind of see how this almost looks exactly like a triangle, but it's just a series of parallel lines and they are intersected. So same process. I could say that AB, the ratio of AB over BC, is going to be equal to, well, what's across from AB? DE over what's across from BC? EF. All right, or we could say AB over DE, so we could go straight across, is going to be equal to, and then I have to stay on the same transversal, BC over EF. All right, so let's try. I'm just going to do one of these here. 45 over, so this section over the one below it, 18, is equal to, what's across from the 45? 52 over what's across from the 18? X. Now we're going to cross multiply. 45x is equal to 936. Keep solving. X is equal to 20.8. All right. Couple more. They give you the same type of issue. 27 over 18 is equal to, now I go over to the X, over, there is not an actual value there, so I have to solve. So 32 minus 18 tells me that this section right here is 14. So now I have something to set it over there, and I'm going to cross multiply. 18x is equal to 27 times 14, 376, divide by 18, x is equal to 21. All right, very good. So now we have a story problem. A reflecting pool is separated by walkways parallel to Lincoln Street and Jefferson Street, which are each parallel to each other. So we have Lincoln Street, Jefferson Street, and then there's walkways here, and they're telling us that these are parallel to each other. The city wants to add additional tiling around the pool. How much does X feet represent? So they're going to end up putting tiling all around here. We have to figure out what X is. Now there's three different sections. So when we set up this, we always want to find a section that has both values. So I'm looking at 60 over 72. that ratio is going to be the same as, so 60 over 72 is going to be the same ratio as x, which we're solving for, over 24. We also could have, oh, sorry, I didn't even notice this was a y. I just happened to choose the right one. This is 24 over y. Okay, so I can't find y, or I can't use this section and this section because we'd have two variables. So I have to use that one to anchor it in. So we cross multiply. 72x equals 1440. Divide by 72. X equals 20 feet. Now they want us to find y. So now we are looking here. I know I have to have 24 over y. That is equal to, well, I just found that this is 20. So I actually could choose between either one of these. However, I always stand by not, whenever possible, not using the one that you found, just in case you made an error. So let's go with this one because we cannot possibly get it wrong. 72, we get 60y equals 24 times 72 is 1,728. Divide by 60, y equals 28.8 feet. Oops, I'm sorry. And that's it for that part. Now there's one final theorem in the chapter, the triangle angle bisector theorem. This says that if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. All right, so what that means, if I have a triangle here, we'll call it triangle A, B, C. Let me grab another color to make this a little easier to see. And I have a ray, AD, that bisects this angle. What this is saying is that the ratio of AB over the segment that's created there, sorry, this will be BD. AB over BD is the same ratio as the other side. AC over DC. All right, there's one proportion. You could also do the side here, AB over AC. So this side over this side is going to be equal to that segment BD over the other segment DC. This one I think is one of the easier ones. So let's try this example. Find the value of x. X is right here. So I'm going to start with 7. 7 over this segment created right here, 2, is going to be equal to x, which is the other side of the triangle, over the segment down here, 3.5. I cross multiply, 2x is equal to 7 times 3.5, 24.5. Divide by 2, x is equal to 12.25. Simple enough. This one, they made it a little more complicated. They want us to find the value of x, and then in part B, find the value of GH and GK. So I still start with one side here, 3x plus 3 over 3x minus 7 is equal to 18 over 12. I'm going to cross multiply. So 12 times 3x plus 3 equals 18 times 3x minus 7. I need to make sure that I distribute So I get 36x plus 36